Hello everyone. If you don't have any previous knowledge with line traces in Unreal Engine, or if you want to learn about them in greater detail, then this tutorial was made for you. In this tutorial, we will go over everything about line traces. Then at the end, to put your new line trace knowledge to use, we will also create Minecraft's building system, allowing you to place and break cubes just like in Minecraft, but in Unreal Engine, completely from scratch, start to finish. This video is pretty long, but that's because we've got a lot to cover. To help navigate this video, I've divided it up into individual chapters. You will find links to each chapter in the description below. In this tutorial, you will learn how to detect things that are in front of the player, understand how each type of line trace works, and most importantly, learn how to use each output hit pin so that you can make line traces do what you want them to do. We will also go over trace channels, object channels, and collision profiles to understand how to better use different types of line traces. And at the end, we will make Minecraft, in which you could place cubes, break cubes, and show an outline of the cube if it's in front of you, or hide the outline when it's no longer in front of you. So let's first start with explaining what line traces are. I will explain line traces using a short drawing animation thingy that I made, and then we will go into Unreal Engine to make our first line trace. A line trace is a line between a start and an end point. If the line collides with or hits anything, we can get the information about what was hit. We could get information like the hit location, hit actor reference, and hit normal. If we were making a building system, we would need to know the position where we could place an object, and for that, we would need the hit location. If the line trace hits multiple things, you only get information about the first thing that was hit, and it doesn't give you information about anything else, unless you're using a multi-line trace. To make a line trace that gets information about what's in front of the player, the start location should be where the player is, and since you want the line to go straight in front of wherever the player is looking, we need the direction where the player is facing. Then we determine how long we want our line to be, and after a small amount of math, which I will cover later, we could get the end point. Now, we have a line that will start at our player's location, and it will end trace length distance away from the player in the direction that the player is looking at. Now let's do the same thing, but in Unreal Engine. I assume that you already have Unreal Engine downloaded. I'm using version 5.1 for this tutorial, but it will work in earlier versions as well. So click on the first person project and select Blueprint, Desktop, Maximum. We don't need starter content or ray tracing, and name the project whatever you like. Click Create. Once it opens and everything loads up, navigate to your content browser by clicking here or pressing Ctrl space. Make sure you're in your content folder, then go to first person, blueprint, and first person character. First, let's find some space in the event graph. And to move around the event graph, just hold right click and move your mouse. Now we will make a line trace that could give us information about what's in front of the player. Right click and type in line trace and click on the line trace by channel node. Make sure you don't open multi-line trace by channel. So first, out of your components panel, drag out the first person camera into your event graph. And if you don't have the components panel over here, go to window and click on components. So this is a reference to this camera over here, which allows us to get the location and the direction of the camera, which is necessary for our line trace. Next, drag out get world location, and since it says first person camera in parentheses, it's also gonna spawn another first person camera. We could get rid of it. Connect this to the start point. Now drag out a get forward vector node. So as you saw in my 2D explanation animation thingy, you need the direction of wherever the player is facing to make the line trace. This returns kind of the X direction of wherever our camera is looking. I'll show you what I mean. So in the viewport, when we click on the camera, we see these red, green, and blue arrows. The blue arrow is the up vector, the green arrow is the right vector, and the red arrow is the camera's forward vector. And since the red arrow is pointing outward from the camera, when we get forward vector, that means that we get the direction that the red arrow is pointing in. Now from here, drag out a multiply node and make a new variable called trace length and set it to a float. Compile to be able to change its default value and set it to 600. Now drag out the trace length variable and get trace length. This allows us to use the value of trace length connected here. So when we multiply the forward vector and trace length, we will have a line that is pointing in the direction that the camera is pointing in, and it will have a length of 600 centimeters. From here, drag out an add node and connect the multiplied result to the add node. And connect this to the end of the line trace. To actually see the line in our level, click on this arrow, actually click on draw debug tape and change it to for duration. We will see the line for 5 seconds because the draw time is 5 and the draw debug tape is set for duration. Right click on the event graph, search keyboard, and click on any of the keyboard events. Go into the details panel and change the input key by clicking on here and then left click. Connect this, so now whenever we left click, we will make the line trace. Compile and save. Now go into your first person map and click on play. Now whenever we left click, we make a line trace in front of us. When a red square shows up, that means a line trace hit something. And after the line trace hits something, the line changes from red to green. Escape to stop playing and go back into the first person character. Now we will make something fun and simple in which whenever you left click and the line trace hits something, it will get destroyed. So from out hit, drag out the break hit result, click on this arrow, and from here, search static mesh and drag out cast to static mesh component. Connect these execution pins together and out from as static mesh actor, drag out destroy actor, compile and save. And here, in the level, when you press play, whenever you left click and the line trace hits something, it gets destroyed. Boom, 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 boom. But if the line hits, for example, this gun, it doesn't get destroyed because it's not a static mesh. And we said when it detects a static mesh, destroy the static mesh, nothing else. Alright, let's backtrack a bit here and go over what these input pins mean. So the line trace by channel node has all of these input pins. The trace channel determines the channel used for the collision test. The line trace will search for objects that block the trace channel selected, visibility or camera, but more on this in a moment. For the trace complex, if it is true, then the trace will test against the actual mesh. However, if it is false, then the line trace will test against simplified collision shapes. For the actors to ignore, it takes in an array of actors that should be ignored in the collision test. So for example, if you made a specific blueprint and you didn't want the line trace to give you information about that blueprint, even if it hit it, like if you just want the line trace to ignore that blueprint completely, then you could add it to actors to ignore, and that will ignore the blueprint you want to ignore. The draw debug type, as you saw before, this allows the drawing of a 3D line that represents the line trace. And we could actually set this to none so that we won't see the line trace anymore. Or we could set it to for one frame so that when we make the line trace by left clicking, the line trace only shows up for one frame. We could also set it to persistent, which means that whenever we make the line trace, it will never go away. It will stay there forever until you stop playing the level. For the ignore self, we want this to be set to true so that the line trace doesn't hit the first person character. If ignore self was set to false, it's possible that the line trace would hit the character that we are in game, but we don't want that. We want to check for things in front of us, not ourselves. Hey guys, I just wanted to let you know that you don't really have to memorize anything in this course because I've put together a cheat sheet with summary notes so that you could quickly review the materials in this course. The link is in the description below. So I've done my best to create an in-depth line trace course in Unreal Engine that helps you get started using line traces. I've spent at least 150 hours on it already and still need to spend some time to make some final touches and post the video. I really hope that this video serves you and most importantly, gives you a great return on your attention. So if this has not helped you, or you think that I could do something better, please let me know in the comments. I'm still very new to making content and would love some feedback. If it has helped you, make sure to like this video and share it with others so they can learn as well. And be sure to subscribe for more tutorials like this. Alright, now let's move on with the video. What does by channel mean in line trace by channel? What does the trace channel mean? So these are channels, and these are the same channels that you have when you're setting up collisions. So if you go over here into the level, and you click on one of these blue cubes, let's say this one, they're called chamfer cubes. In the details panel, actually if you don't see a details panel over here, go into window, and click on details, details 1. And then you could drag it over here. So when the cube is selected, in the details panel, you could scroll down until you find collision. Yeah, collision. And for now, set collision presets to custom. And over here, you have the same channels that you see in the line trace by channel node. In the first person character, set this to visibility. Don't forget that it's set to visibility. Here, when we set the visibility channel to overlap and we play the level, you could see that the line trace doesn't detect our cube. It's just shooting right through. Escape. Now when we set the visibility channel to ignore and we play the level, the cube still ignores our line trace. But if we set the visibility channel to block, then when we make our line trace, the line trace detects the cube. Now if you go back into the first person character and set the trace channel to camera, and compile, and go back into the level, then when you change to overlap, or to ignore, again, the line trace won't detect our cube. But if you set it to block, then when we play the level, the cube detects our line trace and gets destroyed. Alright, so I hope that clarified what by channel means in line trace by channel. Now we will go over the other line trace nodes. The line trace for objects node works similarly to line trace by channel, but instead of looking at the visibility or camera channels, it checks the object responses that are set. Out of object types, drag out a pin and click on promote to variable. You could leave it as object types and compile to be able to change the value. Click on add element and change this to, let's say, pawn. And in the first person map, click on the BP pickup rifle, select the skeletal mesh. So in the details panel, make sure that this isn't selected, but this. And scroll down until you find the collision settings, or just type in collision over here. Once you find collision, click on simulation generate hit events. Click on this arrow and set the collision presets to custom. So these are the same object responses that you see in the first person character over here. These are the exact same. So that we could use line trace for objects, let's replace line trace by channel with line trace for objects. I'm going to leave line trace by channel here because I think we will use it later in this tutorial. So make sure that draw debug tape is set to for duration and compile and play the level. So now you could see that when we make the line trace, the line doesn't detect the rifle. Remember how in the line trace for objects node we're searching for pawn object types? So if you change the collision settings from physics body to pawn and play the level, you could see that the line trace detects the rifle. But if you set the collision settings of the skeletal mesh back to physics body, then when we play the level, it doesn't detect our rifle. However, if you go back into the first person character and you change the object types to physics body, compile, and this is also set to physics body, then when we play the level, the line trace detects the rifle. So as you could see, the line trace for objects node works similarly to the line trace by channel node, except that instead of using the trace channel, it searches for object types. Line trace by profile also works like line trace by channel and line trace for objects, except instead of using object types or trace channels, you use a profile name. Before we see how it works, let's first delete object types and line trace for objects. And you could delete this variable too by pressing the del key on your keyboard, or by right clicking and selecting delete. Also change the draw debug type to for duration, and it's automatically set to 5 seconds, so we don't have to change that. And if you go into the first person map and click on settings, project settings, on the left side under engine, select collision. Here, click on preset. Here you could see a bunch of preset collision profiles from Unreal Engine. Collision presets are basically used when you make a bunch of actors and you don't want to manually set collision settings for each actor. For example, let's say you're making a game and you need to set up collision settings for a weapon actor, a car actor, a projectile actor. Basically, you need to set up collision settings for everything you make. And instead of manually changing each actor's custom settings, if you know that some actors share the same collision settings, you could just set up a collision preset or use one of these presets that are available to you so that you don't have to change collision settings one by one for each actor. Oh, and here you could make trace channels in addition to the visibility and camera channels. You could also add extra object types in addition to the ones that you already have. These presets, from no collision to UI, I believe are in every Unreal Engine project, and the projectile preset comes with the Unreal Engine first person template. So let's create a new one to show you how this works. Here, name it whatever you want. I will call mine test profile. And click over here next to collision response where it says overlap. Click accept. Now come back to the first person character. On the line trace by profile node, type in test profile or whatever you called the profile you just made. Now come back to the level and press play. So you could see that when we are making line traces, they are not hitting anything. Come back to the project settings and come back into collision preset. And come back to the test profile and click edit. Change physics body to block and accept. Come back to the level. And now when we press play, because the rifle has a physics body object type, and because our test profile has physics body set to block, our line trace detects the rifle. If you changed the test profile to block rolled static collisions, then the line trace would also be able to detect the ground, because the ground's object type is set to rolled static. To recap, we could use the line trace by profile node to trace for multiple object types at once, and making presets could also allow you to quickly change collision settings on many different actors in your game without manually going through each one. There are multi-line traces by channel, by profile, and for objects. They work similarly to regular line traces because they give you information about objects that it hit, but they're not exactly the same. Here's an example for you. Here I'm making a line trace in front of the player. If it detects a static mesh, then it will destroy it. Since the multi-line trace node has an array data type for the output, I'm using a for each loop. It will execute these nodes for every object that it gets hit information on. So if 5 objects are in the array, it will check 5 times whether or not the objects are static meshes. In the level, I set up 3 cubes. One has the channel set to ignore, the second one has it set to overlap, and the third one has it set to block. When we play the level and make the line trace, you could see that the line trace is going through the first cube, but it's not actually detecting it. That's because it's set to ignore. But the second one is set to overlap, and you could see a green square here which indicates a hit. This cube was added to that multi-line trace output and was destroyed. And where the third cube was, there is a red square, indicating that the line trace hit it. It also indicates that it's the end of the line. It blocks it, and it doesn't return anything behind it. So even though the ground is a static mesh and the line went through it, it doesn't destroy the ground because the third cube blocked the line trace. I'm not going to go over the shape trace nodes because you definitely won't use them in this tutorial, and mostly because I never used them myself, so I shouldn't talk about them. But I will leave a link to a video in the description if you want to learn about them. Also, I assume that there will be many questions in the comments section about certain things that I might not have explained well in this video, or that I didn't include in the video, or maybe I thought that something in this video was unclear. So I will provide links to resources like videos or forums to clarify some things in the description below. So if you have a question, look in the description and you might find the answer to it, or search the comment section or Google. Also, don't forget to download the line trace cheat sheet to quickly review anything about line traces. This section of the course is crucial when learning about line traces. You will learn how to use the information from the out_hit node to actually do stuff. We will finally put line trace information to use. After I go over this, we will start making the building system. It took me a while to learn how this all works, so I hope that I could help by explaining this to you. But first, let's clean up these nodes a bit. We won't be needing multi-line trace and line trace by profile. Now let's reconnect line trace by channel. Instead of having a separate node for break hit, we could right click and split struct pin to get all the info about the object that was hit. That works perfectly fine. It has the same information as the break hit result, but we should still use the break hit result node because it keeps our blueprint graph cleaner. So right click here and select recombine struct pin and reconnect this. Now let's go over the pins. Blocking hit. This boolean returns true if the trace line hit something and false if it didn't. It's useful for determining whether or not we want something to execute, because usually when the line trace doesn't hit anything, we don't want to run any code. These two pins are the exact same, blocking hit and return value. They return the exact same value, but the return value pin is there in case you only want to know if the line trace hit something, and you don't want any out_hit information. Initial overlap. This will return true if you hit something at the beginning of the line trace. So if the line trace is 1000 centimeters long, then this will return true if you hit something at a distance of 0. Time. This doesn't actually have anything to do with time. It basically tells you the length percentage between the start and the end of where the line trace hits something. So if the line trace has a length of 1000 and it hits something at a length of 100 from the start point, then the output time would return 0.1. Distance. This is basically the same as this, except that it gets the actual distance from the start point of the line trace to the hit point. So if the line trace hit an object, we will get the distance from the start of the line trace to the point where it hit the object. Location. Gets the location of where the line trace hit the object. The location of the hit point is shown by the red square that you saw earlier. If you want to place something in the location where the line trace hit the object, then you could do that with the hit location. This information is crucial for a building system because we need to know the location where we should place an object. Impact point. This is very similar to the location. The only difference is that if you had the trace complex set to true, then it will get the impact point of where the object was actually hit. However, if trace complex is off, the impact point and location will match. The trace complex has to do with collision shapes, for which there is a way to change, but that's beyond the scope of this video. Normal. This gives you the normal line of the object's face that the line trace hit. This is useful for when you want to place specific objects based on the object that you want to place it on. We will also use this when making the building system. It will allow us to determine which side of the block we want to place on. Impact normal. This is like the normal pin. It's only different when the trace complex is set to true. This is like the relation between location and impact point. Physical material. This gets info about the material of the object that the line trace hit. This is often used for changing the sound of footsteps. Let's say you make a game, and you want it so that when the player walks on stone, the sound of the footsteps would be different than if the player walks in grass. You could make a line trace from the bottom of the player to check which material the player is walking on, and depending on the material, change the sound of the footsteps. Hit actor. This gets a reference to the actor that was hit. This has a ton of use cases. We could cast to the actor reference and destroy it, like we did over here. You could also call to any events that the actor has, any variables that it has. You could change the actor's variables. You could basically do anything that's related to the actor that you hit. Hit component gets a reference to the part of the actor that is hit. I just made an actor called Sphere Cube, which is made up of a sphere and a cube. When we print the name of the hit component and make a line trace, then if it gets hit, it will print the part of the actor that was hit, which shows that we're getting the reference to the component that was hit and not the actor itself. If BP Sphere Cube had an actor instead of the cube or instead of the sphere, then if we hit the actor, we could call an event or get a variable or get some information about that actor, similar how we could get information from the hit actor node. Hit bone name. So most skeletal meshes have bones in them, and if you hit a skeletal mesh with the line trace, then this pin will give you the bone name of the skeletal mesh. So if you hit a head bone, you could make it so that in your game, if you shoot an enemy, it tells you if it's a headshot. Hit item and element index. These two, I'm not sure how they work or what they are used for, but if you're using primitive data, then this will give you back information about the primitive data that you hit. I will leave a link to the documentation page that tells you more about it in the description. Face index. I'm not sure exactly what it does, I just know that if it collides with a landscape or a trimesh, it gets the index of the face that was hit. Trace start and trace end. This just outputs the start and end points of the line trace, the ones that you inputted in here. The value of the vectors don't change, it just makes it easier for you to access them if you need them, so that you don't have to go back in your nodes. You could just access them from here. You're now equipped with the knowledge that you need to understand how to make a building system. It's finally time to make it. Open the content browser by pressing Ctrl Space, and in the content folder, right click and select New Folder. Name it Blueprints. Open it and make a blueprint class. Actor, name it BP Cube. This will be the actual object that we will be able to break and place. Open it, and in the components panel, add a cube by clicking on add and selecting cube, and compile and save. Now in the BP first person character, let's make it so that when you right click, you place the BP cube that we just made. So in order to do that, we will have to line trace to get information about what's in front of us. And we could reuse all the nodes that we used to break a static mesh. just select them and press Ctrl C on Windows or Command C on Mac, I think. Move down the event graph and press Ctrl or Command V to paste them. Now select the left mouse button node and next to where it says input key, click on here and right click with your mouse. Now the following nodes will execute when you right click. Next, drag out spawn actor from class. Select the BP cube because that's what we will be placing, and we need a location to place it. So out of the break hit result, drag out location and attach it to spawn transform location. Now go into the level and press play. When you right click, you could place cubes, but for this building system, we don't want cubes to get placed inside each other like this. So let's fix that. Back in the first person character, out of hit actor, drag out cast to BP cube and connect it like this. The cast node will check whether or not the thing we hit is a cube. If it is, then this execution pin will run, but if it isn't, then this one will run. And we only want to place the cube if the line trace detects a cube. Out of hit actor, drag out get actor location to get the cube's location. And spawn in an add node. Since the cube is 100 centimeters long on all sides, we should add 100 to the location. So first, let's test if it works by adding 100 to it in the z-axis. Connect it to the spawn transform location. Go into the level, and from the console browser, drag out BP cube somewhere into the level, or else we won't be able to place anything. Now I'll drag it up a bit. And now play the level. Now when the line trace detects a cube in front of it, it will place one on top, because adding 100 in the z-axis to the cube you spawn means that it will be 100 centimeters higher than the cube it detected. So that means if you subtract 100 from the z-axis, then the new cube will spawn below the cube that you tried to place it on. We could also add or subtract 100 on the x or y axis to spawn the cube on one of the sides. But how do you determine whether you should add or subtract, and to which of the axes? That's where the normal pin comes in. Remember, a normal line is perpendicular to its face. It will allow us to determine which side of the cube the line trace hit. Escape and come back to the first person character. Drag out print string and connect the normal pin to this pink pin in the print string. This will print out the vector of the normal line onto the player screen. And disconnect spawn actor BP cube for now. Go to the level and press play. When you right click and hit the cube with line traces, depending on the side you hit, it will print out different x, y, and z values. If you hit the top, x equals to 0, y equals to 0, and z equals to 1. And here it prints out x equals to 0, y equals to 1, and z equals to 1. On this side it prints the opposite. X equals to 0, y equals to -1, and z equals to 0. So when x equals to 0, y equals to 0, and z equals to 1, that means that the line trace hit the top of the cube. So that means that when z equals to 1, we should spawn a new cube 100 centimeters above the previous cube. Go back to the first person character and delete print string and connect these back together. From the normal pin, drag out break vector 3f. This will allow us to check the x, y, and z values of the normal information. Out of z, search for equals and select this one. And type in 1. Now out of the return pin, drag out a branch node, branch, and connect it like this. Now when we line trace and the normal z vector is equal to 1, we will spawn a cube 100 centimeters above the previous cube. Now we could continue doing this same thing for each of the x, y, and z axes like this, and this actually works by the way. I could place cubes on all 6 sides, and that's how I did it the first time. But it takes repetitive work to set up, and there's a much better way to do this. Delete everything so that your event graph looks like this. And then out of normal, drag out the multiply node, make a new variable called cube length, and change it to a float. Compile to be able to change its value and set it to 100. Connect the cube length variable to the multiply node, and from hint actor drag out get actor location. We didn't have to delete it before. My mistake. Now out of here, drag out an add node and add it to this. And connect this to spawn transform location. And connect these pins like this. Compile and save. Now when we right click, then depending on the side of the cube that it hits, it will place another cube. Now here's a little exercise for you. I want you to extend this blueprint by allowing you to break cubes that you placed. So when you left click, you could break a cube. Since we don't want to be able to destroy static meshes in this building system anymore, you could delete this functionality if you want. So pause the video, do this exercise, and then come back and continue watching. Since we won't be using left click to destroy static meshes, we could delete cast to static mesh actor and replace it with cast to BP cube and connect the pins. Now when I left click and a cube is detected in front of the player, it will destroy the cube. Oops, I should connect this. Compile and save, and now let's test it. So I'm placing a bunch of cubes, and I could left click to break them. Now we will make it so that whenever the player looks at a cube, its edges change color. Similarly to how whenever you're looking at a block in Minecraft, an outline appears. There are many ways to do this, but the simplest one I've done, and the one that works pretty well, is the following. Come back to BP Cube, and in the Components panel, click on Add, and search for Box Collision. Make sure it's selected, and in the Details panel, change Box Extent to 50 by 50 by 50 to make our collision box the same size as the cube. Then change the line thickness to 5. Now you could clearly see the outline. Now scroll down until you find Hidden in Game. Make sure to set it to false because we want to see the box collision in game. Also set visibility to false. We will use blueprints to show this collision box when the cube is in front of us and hide it when the cube is not in front of us anymore by toggling visibility. Compile and save. Go into the event graph and delete these nodes. Now search for custom event and name it show outline. From the components panel, drag in the box. This is a reference to the outline box that we just made. Drag out, set visibility, connect it to here, and toggle on new visibility. Make another custom event and call it hide outline. Copy and paste these nodes over here, connect them up, and make sure that set visibility is set to false. So when we call this event, we will make the box outline visible, and when we call this one, we will hide the outline. We will call them from the first person character, depending on whether or not the cube is in front of us. Compile and save. go back into the first person character and find some open space on the event graph. Get an event tick node. Copy the line trace nodes from before and paste them next to event tick. Connect them together. This will make a new line trace every frame because these nodes make the line trace and the event tick node executes for each frame, which is important because we want to check every frame whether or not the cube that was in front of us before is still in front of us. At a hit actor, cast to BP cube and connect it here. We could call the show outline event from here. So drag out from as BP cube show outline. Compile and save. Now go back into the level. And you could see that when the cube is in front of you, the outline appears. Now let's make it able to disappear. So go back into the first person character. Out of as BP cube, select promote to variable. Call it BBCubeRef, which stands for BBCube reference, and disconnect the show outline pins. And connect the nodes like this. Drag out BBCubeRef from your variables and select get BBCubeRef. Drag out hide outline. Move this over here and also drag out is valid. And click on the one that has a question mark on it. This checks whether or not the reference we have actually exists, which helps us avoid errors. Try it without the isValid node if you want. You should see for yourself how it works. Connect this to line trace by channel, and if it is valid, we should connect it to hide outline, and if it is not valid, connect it to cast to BP cube. And connect this also to cast to BP cube. When the cube is in front of you, the outline appears, and it disappears when the cube is no longer in front of you. But we still see a bunch of line traces being drawn in front of us. So in order to turn that off, just go into every single line trace node and set draw debug type to none. That's all of them. So you could right click to place blocks, left click to break blocks, and when a cube is in front of you, its outline will appear, and when it's no longer in front of you, it will disappear. Are you serious about learning Unreal Engine? If you are, then you have to commit. Commit to learning and improving your skills. Subscribe to this channel so that I could help you on your journey.